Example 2 has things in function notation again. We've got a graph that's given to us, and it's got one point labeled there. We're also going to label this point 1, 1, and this point -1, 1. And at this situation, you might say, hey, I recognize that graph. That graph is our 1 over x graph. And this graph, even though it doesn't have it on here, we'll need to add this in. It has an asymptote here at x equals 0 and has an asymptote here at y equals 0. And what we're going to do is we're going to look at the equation that we want to graph. Y plus 4 equals f of 1/2 x plus 1. We're going to rewrite this so the y is by itself by moving the 4 over to the other side. Moving from left to right, the first thing we see is the half. That is going to be inside the function. It's going to be horizontal, and it would be a horizontal stretch. We would multiply our x values by 2. Then we come across the plus 1. That's horizontal, and it'll be a horizontal translation. We'll move 1 to the left. And finally, the minus 4. That'll be a vertical translation. That'll move things 4 down. When you're dealing with the reciprocal graph, the only points you need to label are what happens to 1, 1 and -1, -1. Again, that's nice because neither of those points are fractions. Every other point that you would pick on your reciprocal graph has fractions. It's not to say you can't do more points if you want to, but those are the only two that you'd be required to do. In addition to that, we're also going to be looking at what happens to our asymptotes. What happens to x equals 0 and what happens to y equals 0. So when I set things up, I do my arrows for my stretches and compressions and then my arrows for my translations. Above my stretches and compressions, I only have 1. We're going to multiply our x values by 2. And with my translations, I have 2. I have 1 to the left and 4 down. Again, take your time with your mental math. Multiply your x coordinates by 2. Check your answers as you go that you're not forgetting negatives or adding negatives. Then move them 1 left and 4 down. And we get our new points. Now with our asymptotes, one thing you're going to find with asymptotes on a rational graph at x equals 0 and y equals 0, because they're starting at 0, when you multiply x and y by anything, they're going to stay at 0. So the only thing that's going to affect our asymptotes is whether they're moved left, right, up, or down, whether there's any translations. So because we're moving 1 to the left, our x equals 0 becomes x equals -1. And because we're moving 4 down, our y equals 0 becomes y equals -4. Often we'll graph things on the same graph. This one gets a little bit busy when you graph all these asymptotes, the original asymptotes and your new asymptotes all on the same graph. So to keep things clean and simple, we're going to graph our new graph on a separate grid. So draw some axes. The first thing we're going to start with, if you have a red pen, I like to draw asymptotes in red. So we have a horizontal asymptote at y equals -4, and we have a vertical asymptote at x equals -1. We can now draw our new points. We have a point at 1, -3. Label that point, and a point at -3, -5. With your asymptotes and those 2 points, it's enough to draw your final graph towards your asymptotes and finish your graph. Now this was given to us in function notation. Our original function here is 1 over x. That would be the explicit equation. Or we could say that our original function f of x was 1 over x. If I wanted to find the explicit equation for this blue one, I'm going to have to think, how do I write this as an explicit equation? Again, our normal function f of x is 1 over x. So what does this mean? Well, anything outside the function stays outside the function. So I'm going to have a minus 4 at the end because I have a minus 4 outside of the function. But whatever's inside the function, if you think about how functions work, if I asked you to do f of 7, you'd replace the x with a 7 and get 1/7. If I asked you to do f of 15, you'd replace the x with 15 and get 1 over 15. Now we're asking you to do f of 1/2 x plus 1. Whew. What does that mean? You replace the x with a 1/2 x plus 1. And it will look like this. 1 over 1/2 x plus 1. And this is our explicit equation for the blue graph that we just wrote. Now ask yourself, because you could be given this same question with the explicit forms instead of the function form. If you were given that explicit equation, would you recognize this is a 1 over x graph? Because there's an x on the bottom. And then say, where the x is, that's where inside of my function, I have a half, which is a horizontal stretch by 2, 1 to the left, and then finally 4 down. I think that equation in the black box seems a lot harder than the equation in the green box. And for the 1 over x graphs in particular, they're, in my opinion, hardest to see that way. But you could get an equation that just looks like this and asks you to graph without even giving you the original graph because it's one of the ones that you know and have memorized. Whew, that would be complicated. Questions for practice on this one? 7-11.